By popular demand, we're doing a mixture or dilution problem. If we start with 16.0 ounces of a 91% alcohol solution, how much water do we add to get 25.0 ounces of a 55% alcohol solution? Note that we're not necessarily going to end up with the 25.0 ounces. It's possible that the water we would need to add to bring it from a 91% concentration down to a 55% concentration would be more than the 9 ounces that we have between 16 and 25. So here's what we want to do, focusing on the concentration. I want to figure out how much alcohol, just pure alcohol that we have to start with, how much alcohol we're added in, and end up with the desired volume of just pure alcohol. So I'm using this word part that should get you thinking about what we did with percentages. Another thing is what we have here is we have the part alcohol added in, but what we're planning to do is add in water. Is that going to be a problem? It turns out that no, it's not going to be an issue because we're still going to have water, the amount of water represented later on in our equation. Okay, going back to the part equals the percentage of the base, we can rewrite the original part alcohol is equal to the original percent concentration of alcohol times the original volume that we have. So in this particular problem, that's going to be 0.91 as our percentage times 16. For the alcohol that we're adding in, that's going to be the percent concentration of the added substance, which in this case is 0, times the volume of the added substance, which we don't know. The desired part alcohol is going to be the percent concentration of the desired mixture, so 55% converted to a decimal is 0.55, times the total volume of the mixture, which we don't actually know. We're hoping it's going to be at least 25, but we don't know that for sure. Rewriting that more as an equation, what we have is we have the original percent concentration times the original volume, plus the concentration of whatever we've added in times the volume of that, and that should equal the percent concentration of the desired mixture times the total volume of the desired mixture. Let's let W equal the ounces of water that we add in. That's what we're trying to find in this problem. With these numbers, that becomes 0.91, so that's 91%, times 16, so there's our 16 ounces, plus 0%, because water doesn't have any alcohol in it, times the number of ounces of water, equals 55%, or 0.55, times the total volume. So what I did here was I added the original volume plus the amount of water that we're pouring in to find the total. Putting that equation front and center, let's go ahead and solve it. The first thing I want to do is distribute through to get rid of some of these parentheses. Multiply things out. 0.91 times 16 becomes 14.56. 0 times W becomes 0. On the other side of the equal sign, we distribute the 0.55 through to get 8.8 plus 0.55W. Subtract 8.8 on both sides to combine like terms, also add 0 in, and this becomes 5.76 equals 0.55W. Since 0.55 is multiplied in, divided out, we end up with 10.472727272 equals W. The bar over the 72 means that it's repeating. This is not our final answer. We want to pay attention to significant figures. It looks like all of the numbers that we're working with have 3 significant figures. Oh, I should have put 91.0. Okay, well, we're pretending this is 91.0% alcohol. So we have 3 sig figs across the board. And that means the answer we would end up with is 10.5 ounces of water. So look to the tenths place. That's the third significant digit. The digit right after it is 5 or more, so we round up. So 10.5 ounces of water. And notice this does put the total above the 25 ounces total combined, because we started with 16 and we added in 10.5, so we ended up with 26.5 ounces. So I guess pour 1.5 ounces off and you're left with your desired concentration. Thank you.